This short video is going to demonstrate how to employ a macro to basically drill the drain holes in a fuselage. So here I've got just a block, and first thing I'm going to do is I'm going to sneak some surface repair into this video, just so we can make this belly pan. And so I'm just going to take this block and I'm going to split it a couple of times, and then we'll mark some edges. And then delete these guys. Oh, looks like we got a bit too much here. Okay. Fill that up, and then we're done. And then I'm just going to change the name of this to bottom pan, and then we'll close that, and that'll be the part we'll be drilling the holes in. So to create the holes, we're basically just going to create a bunch of primitives. We're going to explore kind of two options. One is we're going to make cylindrical holes by creating cylinders, and the other one is we'll create prismatic holes by creating blocks. And so it's a bit long, the macro, but you can, if I collapse all of the methods, you can see the premise is quite simple here. So we've got kind of a main method to read in some data from a file, right? And this file looks like this. It's got a couple of columns. We have the name. So each hole will get a name. It has an X, Y, and Z position. It has a radius, and it has a height. Sorry, this is the diameter, not the radius. And this is the kind of the height in the Z direction. And so this particular file has got 30 holes, and they've got slightly different diameters, so they're increasing in one direction. So really it's just two rows of holes with increasing diameters from one side to the other. And so the first thing we're going to do is just take a look at this main method. So we read in the file, we kind of store that data, that information about all the holes, and then depending on which option you select, we'll either make cylinders or we'll make rectangles or prisms. And then if you want, we can then intersect them with the belly pan component, right? The block part and the bottom pan surface, or we could just leave them as they are. And so just for a first run, we'll change this to false. This will just create the components. So let's go back to here, and before I create them, I'm going to make a copy of our block here, just in case we screw something up. And so I'm going to run this macro using my little shortcut here. It's a little star I've just linked to my path, so I don't have to keep browsing over to that macro file. And you could get these by simply going to customize and then drag them into position. But I'm going to hit the button here, and you can see my cylinders were created using the dimensions in my file. You can see each one is a separate part. It has just the default surface name. And now you can use these in surface repair to make the intersects with our bottom pan here, and then remove the access and name the remaining kind of circles accordingly if we had wanted them to have individual names. For example, if you want to track mass flow rate through particular holes. But we didn't do that step, and that's the intersect step in the macro. And so what I'm going to do is I'm going to delete all of these, and we're going to go to the macro, and we're going to enable the the intersection. So after creating the parts, we're gonna intersect them with our block component. And the reason I specify the surface as well is just to lighten the load. Because if this contains the entire vehicle, then if we grab all of the surfaces for that vehicle, it's just going to take longer to make the selections. So that's why I've made a subset. And so now I'm going to run that macro, and we'll see the parts get created. Then a new scene will open, and we can see our cuts being made. Right, and all that's really happening, it's literally just the same thing that happens in a surface repair operation, where you grab these faces, add them to the first set, you grab the cylinder, add them to the second set, perform the intersect, and then I use a geometric range to grab the faces inside the circle and assign to them the same name as I had on the cylinder. And this way you have a named surface that can then become an internal interface and can become a report to track mass flow, for example. So that's basically the gist of the macro here. And what I'm going to do is I'm just going to run the same thing again, but this time we're going to make this false, and so this will create the prisms instead of the cylinders. And in this particular case, what I'm doing is I'm taking the diameter dimension from the input file, and I'm calculating the area and then figuring out what the dimensions of the prism need to be to maintain the same cross-sectional area. So this basically allows you to replace cylindrical holes with square holes in order to reduce the required mesh to capture them. And I went on a tangent when I was about to explain what's going on in this macro. The main method is over here. Basically, we read in the data, we collect the data, and then we create the cylinders or prisms, and we do the intersection. That's it. And then these methods here just contain the code that was basically recorded from a macro to create a prism or to create a cylinder, to read the data in from a text file, and to do the actual hole cutting. You can see this is just, straight, mostly recorded code from, entering surface repair and all of these things becoming initialized. And then the last one here, this is actually a class. So this is like a new object type that I've created just to store the data. It's a neat, convenient way to store information. So I made an object called hole spec. Every time I read a line from the file, I create a new hole spec. The hole spec contains the data that was on that line, like the name, the position, diameter, height, and then some other things that I assign later, like the prism dimension and the actual part that gets created from this information, which happens in a different method. But this is basically a convenience class for storing information. And that's it. So now that we've changed it to false for cylinders, if I run this macro one more time, we can see now we've got rectangles. And you can see it runs noticeably faster because of the smaller number of triangles. And we can just take this to surface repair. We can give it a closer look. You can see that all the cuts have been made, and it does a pretty good job of not grabbing anything outside of the zone that's been cut. It uses a tiny bit of I think a 1 millimeter tolerance around it. So if you happen to have a triangle that's smaller than a millimeter, it might get lumped into that patch. So just keep that in mind. Anyway, I guess that pretty much demonstrates the use of this macro, and I hope you guys find it helpful.